Today we'll discuss ISI's MSQMS 2019 QMA paper, and the first question is, both roots of the quadratic equation x square minus 63x plus k equals 0 are prime numbers. How many values of k are possible? Now suppose the roots of this equation are alpha and beta. Now we'll get alpha plus beta as 63 and alpha into beta is k. Now this alpha is prime and beta is prime. Now since this sum is an odd number, that means one of the number it must be odd and the other number it must be even. So say let alpha is odd and let beta be even, and the only even prime number possible is 2. So that means value of beta is 2. If the value of beta is 2, then value of alpha is 61. In that case, we'll have the value of k as 61 into 2 and it'll be 122. So the number of values of k which are possible is simply 1, and that's your option B. Now question number 2 is, we'll need to evaluate this integral, which is I equals integration from 0 to a under root x plus under root x plus under root of a minus x dx for a greater than 0. Now we know that integral of 0 to a fx dx is equal to integral of 0 to a f a minus x dx. So we'll replace this x with a minus x. So we can write integral from 0 to a under root of a minus x upon, now this is under root of a minus x, and here it will be simply under root x dx. Now what we'll do is, we'll add these two integrals, we'll get 2i and it'll be equal to 0 to a. Now denominator is same, so it'll be under root x plus under root of a minus x, and here it'll be under root x plus under root of a minus x dx, which will cancel. So it is nothing but this integral from 0 to a dx. Now integral of dx is x and it'll be simply a. So value of this integral is nothing but a by 2, and that's your option B. Now question number 3 is, the nearest among the following options for the value of 9.02 to the power 3 by 2 is. Now we'll use calculus for this. So we'll assume a function y equals x to the power 3 by 2. We'll take x as 9. We'll take delta x as plus 0.2. Now we need to find the value of y plus delta y. Now if we put x as 9, we'll get y as 3 squared to the power 3 by 2, and it'll be simply 27. Now we'll find delta y. So we'll differentiate this function. We'll write dy by dx will be 3 by 2 x to the power 1 by 2. Now we can write delta y as 3 by 2. Now this is 9 to the power 1 by 2 into delta x, which is 0.02. Now this is 0.01, and here it will be 3 into 3, 9. So it will be 0.09. So this value will be simply equal to y plus delta y, which is 27.09, and that's your option A. Now question number 4 is, number of positive integers which are less than or equal to 1000 and are not divisible by any of 17, 19 and 23. So what we'll do is, first we'll find number of numbers which are divisible by either 17 or 19 or 23. Now it'll be equal to number of numbers divisible by 17 plus number of numbers divisible by 19, number of numbers divisible by 23, minus number of numbers divisible by 17 into 19 minus 19 and 23 minus 17 and 23, and then plus number of numbers divisible by 17, 19 and 23. Now this first one is greatest near function of 1000 by 17 plus greatest near function of 1000 by 19, greatest near function of 1000 by 23 minus greater than a function of 1000 by 17 into 19 minus greater function of 1000 by 19 into 23 minus 1000 by 17 into 23 and then plus greater than a function of 1000 by 17 into 19 into 23. Now this value is 58, this value is 3 and this value will be 0. This is 52, this value is 2, this value is 43 and this value is 2. So number of numbers which are divisible by either 17 or 19 or 23, they are 146. So the number of numbers which are not divisible by any of them will be simply 1000 minus 146, which is nothing but 854, and that's your option A. Now question number 5 is, we are given this limit n tends to infinite 1 plus a by n plus b by n square to the power 2n, and it is equal to e square. We need to find the value of a and b. Now this is 1 to the power infinite form. We'll directly use shortcut, which is e to the power limit n tends to infinite gx, which is 2n, into fx minus 1, which is a upon n plus b upon n square, and it will be equal to e square. And we'll multiply n and n will cancel. So this limit will be simply e to the power 2a, which is equal to e square. That means value of a is 1, and this limit, it doesn't depend on b. So b can be any real number. So answer to this limit will be a equals 1 and b is any real number, and that's your option C. Now question number 6 is, we are given a function between minus 3 and plus 3, and it is defined as log 3 plus x minus log 3 minus x upon x if x is unequal to 0, and it is C if x is equal to 0. Now it says if f is a continuous function, we need to find value of C. So if f is continuous, then this C will be equal to this limit x tends to 0 log 3 plus x minus log 3 minus x upon x. Now this is 0 upon 0 form. So we'll use L'Hopital's rule. We can write limit x tends to 0, and here will be 1 upon 3 plus x minus 1 upon 3 minus x into minus 1 upon 1. Now we put x as 0, we'll get this C as 2 by 3. So this function will be continuous if the value of C is 2 by 3, which is none of the above, and that's your option D. Now question number 7 is, let x naught greater than 0 and xn be defined recursively by xn equals under root of 6 plus xn minus 1, where n is greater than or equal to 1, then this limit n tends to infinite xn is. Now we can write this xn as under root of 6 plus xn minus 1. We can write this as xn square, it will be 6 plus xn minus 1. Now what we'll do is we'll subtract xn minus 1 square from it. So it will be xn square minus xn minus 1 whole square, and if we take minus common here, we'll get xn minus 1 square minus xn minus 1 minus 6, and if we factorize it, we can write this as xn minus 1 minus 3 and xn minus 1 plus 2. Now here critical points are 3n minus 2, and since x naught is greater than 0, we'll take two cases. Case 1, if x naught is less than 3, and case 2 if x naught is greater than 3. Now if x naught is less than 3, then if we add 6, we'll write 6 plus x naught will be less than 9. That is under root of 6 plus x naught will be less than 3. We can write x1 will be less than 3, and using same iteration we can write xn will be less than 3. Then in that case this function will be bounded above. Now if xn is less than 3, then this value will be negative, this value will be positive, and then we have this minus sign here, so it will be minus and minus plus. So we can write xn square minus xn minus 1 square, and it will be greater than 0, that is xn is greater than xn minus 1, that is the sequence is monotonic increasing. So if the sequence is bounded above and increasing, that means this sequence it is going to converge. Now what about the second case? In the second case, when x0 is greater than 3, if we add 6, we'll get 6 plus x0 will be greater than 9 under root of 6 plus x0 will be greater than 3, that is x1 is greater than 3. If we add 6, again if we take square root, we'll get x2 greater than 3. So from here we'll get this xn, it should be greater than 3. So in this case it is bounded below. Now if xn is greater than 3, then this expression will be positive, this is also positive, and here we have this minus sign. So we'll get xn square minus xn minus 1 square, it should be less than 0, that is xn, it should be less than xn minus 1. That means this sequence is now a decreasing sequence. So if the sequence is bounded below and monotonic decreasing, that means the sequence it will converge. Now what about if x0 is 3? If x0 is 3, then this sequence will be a constant sequence, and we know that a constant sequence is a convergent sequence. So this sequence will be convergent for all the possible values of x0. Now we'll need to find this limit n tends to infinite xn. For that what we'll do is we'll take this limit n tends to infinite both sides. Now suppose this limit is L. So we can write L equals under root of 6 plus L, that is L square minus L minus 6 equals 0. That is the value of L is either 3 or the value of L is minus 2. Now since this sequence it contains positive terms, its limit point cannot be negative. So for the sequence, the value of this limit is simply 3. So this limit n tends to infinite xn will be 3, and which is none of the above, option D. Now question number 8 is, we need to find maximum value of cos alpha 1 into cos alpha 2 up to cos alpha n under the condition that cot alpha 1 into cot alpha 2 into cot alpha n equals 1. Now from the second expression we can write cos alpha 1 into cos alpha 2 up to cos alpha n will be equal to sin alpha 1 into sin alpha 2 up to sin alpha n, and suppose sum of this series is s. Now we multiply them, we can write s square will be equal to sin alpha 1 into cos alpha 1 sin alpha 2 into cos alpha 2 up to sin alpha n into cos alpha n, and what we will also do is we'll multiply 2 n times. So it will be 2 into 2 into 2 n times. So we can write 2 to the power n into s square will be sin 2 alpha 1 into sin 2 alpha 2 up to sin 2 alpha n. Now we know that maximum value of any sign is 1. So maximum value of sin 2 alpha 1 will be nothing but 1. So this right hand side is always less than or equal to 1. So from here we can write s square will be less than or equal to 1 upon 2 to the power n, or this s will be less than or equal to 1 upon 2 to the power of n by 2. So the maximum value of cos alpha 1, cos alpha 2, cos alpha n is 1 upon 2 to the power n by 2, and that's your option A. Now question number 9 is, we need to find number of distinct real roots of this equation in the interval minus pi by 4 to plus pi by 4. What we'll do is we'll write R1 as R1 minus R2, and we'll write R2 as R2 minus R3. So we can write this as sin x minus cos x, and here will be cos x minus sin x. This is 0. Here will be 0. We can write sin x minus cos x, and then cos x minus sin x. Here will be cos x, sin x, and it will be 0. Now from the first and second row, we can take sin x minus cos x common. So we can write sin x minus cos x whole square will be 1 minus 1, 0, 0, 1 minus 1, and then we'll have cos x, and sin x, and this value will be simply 0. So from here we'll get this condition that the value of tan x is 1, or if we expand it, we can write sin x plus cos x and then plus 1, and here will be plus cos x equals 0. That is, the value of tan x is minus 2. Now if we look at graph of tan x, it is an increasing function between minus 90 and plus 90. Now we need solution within this interval from minus pi by 4 to plus pi by 4. So it will be from minus pi by 4 to plus pi by 4. Now in minus pi by 4, value is minus 1, and in plus pi by 4, value is plus 1. So we'll get one solution when tan x is 1, and there will be when x is pi by 4. But tan x cannot take the value minus 2 in this interval. That means the number of distinct real roots is only 1, and that's your option C. Now question number 10 is we need to find the value of this series. Now we know that 1 plus x to the power n, it is C0 plus C1x plus C2 x square plus C3x cube, and this series will continue, and 1 minus x to the power n will be C0 minus C1x plus C2x square minus C3x cube, and again we'll continue. Now we'll subtract second from first. We can write 1 plus x to the power n minus 1 minus x to the power n, and it will be 2 times C1x C3x cube, and this series will continue. Now we'll put x as 2. If we put x as 2 and if we divide it by 2, we can write 3 to the power n minus 1 to the power n upon 2, and it will be equal to C1 into 2, C3 into 2 cube, and this is the same series that we need. So answer to this question is this option C, 3 to the power n minus 1 to the power n upon 2. Now here the question is, suppose alpha, beta and gamma are the roots of this equation x cube plus px square plus q equals 0, then we need to find the value of d, this determinant. Now for this equation, if we write alpha plus beta plus gamma, it will be simply minus p, and if we write S2, which is alpha beta gamma alpha, it will be simply 0, and alpha into beta into gamma is minus q. Now if we divide second with third, we'll get 1 upon alpha plus 1 upon beta plus 1 upon gamma is 0. Now in this determinant, if we take R1 as R1 plus R2 plus R3, we'll get 0 here, 0 here, and 0 there. So this entire row will be 0. That means the value of this determinant is nothing but 0, and that's your option A. Now question number 12 is, let alpha and beta be distinct roots of this equation. Now we can write this equation as A into x minus alpha into x minus beta equals 0. We are given this limit x tends to alpha 1 minus cos ax square plus bx plus c upon x minus alpha whole square. Now this is 0 upon 0 form. Now we'll use standard limit. So we can write limit x tends to alpha, and this is 1 minus cos ax square plus bx plus c upon ax square plus bx plus c whole square into ax square plus bx plus c whole square upon x minus alpha square. Now this is standard limit, which is 1 by 2, and we can write this as limit x tends to alpha. Now we'll write this equation as ax minus alpha into x minus beta. So it will be a square x minus alpha square into x minus beta square upon x minus alpha square. Now this alpha will cancel, so we'll get this limit as 1 by 2 a square into alpha minus beta whole square, and that's your option C. Now question number 13 says a box contains exactly 5 chips, 3 red and 2 white. Now it says chips are randomly removed one at a time without replacement until all the red chips are drawn or all the white chips are drawn. What is the probability that last chip drawn is white? Now this last will be white if we get white in first 2, or if we get white red and white in third, or if we get white red red and white in fourth. These are 3 possible cases. Required probability will be, now this is white into white. Now probability of drawing a white chip is 2 by 5 into 1 by 4 plus, in this case it will be 2 by 5, red is 3 by 4, and then white is 1 by 3 into, now this we have 2 cases, WRW or RWW. So we have to multiply it with 2 and then plus, here it will be 2 by 5, 3 by 4, 2 by 3 into 1 by 2, and here we have factorial 3 upon factorial 2 possible combinations of WRR, so it will be 3, so we have to multiply it with 3. So this value will be simply 1 by 10 plus, now here 3 will cancel, it will also cancel, so this is 1 by 5, here this 4 will cancel, 3 will cancel, and we'll get this as 3 by 10. So it will be 4 by 10 plus 2 by 10. So it will be simply 6 by 10, which is 3 by 5, and that's your option D. Now question number 14 is, there are 7 horses in a race. Mr. Murthy selects 2 horses at random and bets on them. What is the probability that Mr. Murthy selected the winning horse? Now total number of ways in which Murthy can select 2 horses is 7C2. Now we need to find this probability that he has selected the winning horse. That means one of the horse, it must be the winning horse, and then he can choose this other horse in 6C1 ways. So it will be simply 6, and then here will be 7 into 6 into 2, which is 2 by 7. So this required probability is 2 by 7, and that's your option B. Now question number 15 is, we need to consider this function fx, which is mod of x minus 11 plus x minus 12 up to x minus 31, and we need to find minimum value of this function. Now this function, it closely resembles mean deviation, and we know that mean deviation about median is minimum. So this function will assume its minimum value if we take this x to be median of this series, which is 11, 12, 13 up to 31. Now what is the median of this series? The middle value of this series is simply 21. So this series will assume its minimum value at 21. So if we put x as 21, we'll get f minimum, and this value will be simply 10 plus 9 plus 1 plus 0, and then we'll get the same series. So we'll multiply it with 2. So it will be n plus 1 by 2 into 2, which is 110. So the minimum value of this function is 110, and that's your none of these, option number D. Now question number 16 is, let fx be differentiable at all x and let f dash x be greater than or equal to 2. Then if f1 is equal to minus 2, then which of the following is true about f6? Now using Lagrange's mean value theorem, we can write f6 minus f1 upon 6 minus 1 will be equal to sum f dash c, and we know that f dash x is greater than or equal to 2. Now we can write f6 minus, now what is f1? f1 is minus 2, so it will be minus 2 and it will be greater than or equal to 10. That is value of f6, it should be greater than or equal to 10 minus 2, which is 8, and that's your none of these, option D. Now question number 17 is, the smallest integer satisfying this inequality is. Now we look at domain of this function, then x plus 2, it should be greater than 0. That means x is greater than minus 2. Now we are looking at integral values of x. Now x, it cannot take the value minus 1, 0 and plus 1. That means we are talking about the case where x square is greater than 1. Now when the base is greater than 1, if we take anti-log, sign of inequality does not change. So we can write 2 plus x, it should be less than x square. Okay? X square minus x minus 2, it should be greater than 0. We'll get minus 1 and 2. So this is plus, minus and plus. So this value, it should be either less than minus 1 or greater than plus 2. Now the condition here is x is greater than minus 2, and it cannot take the value minus 2, minus 1, 0 and 1. So the smallest integer which satisfies this inequality is at 3, and that's your option B. Now question number 18 is, we are given this function fx. We need to find derivative of this function n times at x equals 0. Now we differentiate this function n times, then here will be n x to the power n minus 1 for the first time, and then it will be n minus 1, again it will be n minus 1, n minus 2. So we differentiate this function n times, we'll get factorial n here. Now we also know that nth derivative of sine x, it is nothing but sine n pi by 2 plus x. So we can write this as sine n pi by 2 plus x. In the same way, nth derivative of cos x is cos n pi by 2 plus x. Now here will be factorial n sine n pi by 2 and cos n pi by 2, and here will be a square and a cube. Now if we put x as 0, we'll get this first row as factorial n sine n pi by 2. This is cos n pi by 2, and we'll get the second row as factorial n sine n pi by 2 cos n pi by 2 a square and a cube. Now since we have two rows identical, this value is 0. So nth derivative of this function at x equal to 0 is 0, and that's your option B. Now question number 19 is, if mod of a sin square theta plus b sin theta cos theta plus c cos square theta minus 1 by 2 a plus c is less than or equal to k by 2, we need to find the value of k square. Now let this expression be e, and what we'll do is we'll multiply and divide everything with 2. So we can write 1 by 2, and then there's a, then 2 sin square theta plus b 2 sin theta cos theta plus c 2 cos square theta, and then minus a plus c. Now we'll take a together and c together. So we'll write 1 by 2, and here will be a minus 1 plus 2 sin square theta. This is b sin 2 theta plus c 2 cos square theta minus 1. Now this is minus cos 2 theta, and this is plus cos 2 theta. So we can write this as 1 by 2, and here will be b sin 2 theta plus c minus a cos 2 theta. Now this is a sin theta plus b cos theta, and we know that a sin theta plus b cos theta is always less than or equal to under root of a square plus b square. So it will be less than or equal to 1 by 2 under root of b square plus c minus a square. Now it says this value is equal to k by 2. So value of k square will be b square plus c minus a whole square, and that's your option A. Now question number 20 is, if in equals this integral from 0 to pi by 4 10 to the power n theta d theta, then I8 plus I6 equals. So if we add I8 plus I6, we'll write this integral from 0 to pi by 4, and then it will be 10 to the power 8 theta plus 10 to the power 6 theta d theta. Now here we'll take 10 to the power 6 theta common. So we'll get I8 plus I6 will be 0 to pi by 4, 10 theta to the power 6, and this is 1 plus 10 square theta, and 1 plus 10 square theta is secant square theta d theta. Now we let 10 theta equals t. And we take 10 theta as t, then secant square theta d theta will be simply dt. So we can write I8 plus I6 will be this integral from 0 to 1 t to the power 6 dt, which is 1 by 7, and that's your option A. Now here the question is, we need to find number of positive integral solutions of the equation x square minus y square, and it is 3906. Now we can express 3906 as prime powers of 2 into 3 square into 7 into 31. Now we can express this left hand side as x plus y into x minus y, and here will be 2 into 3 square into 7 into 31. Now we have only 1 2 on the right hand side. That means out of these two, one of them will be even and the other one it should be odd. Now if x plus y is even, say 2m, and x minus y is odd, say 2n plus 1, then we'll get x as 2m plus 2n plus 1 divided by 2, which is not an integer. In the same way, we won't get any integral value of y. So number of positive integral solutions of this equation will be simply 0, and that's your option C. Now it says, for which of the following option given below the following system of equation is consistent. Now first we'll find delta, and delta will be 1, 3, 1, minus 1, minus 2, 1, 3, 7, and minus 1. Now if we expand it, we'll get 1, and then 2 minus 7, minus 3, 1 minus 3, plus 1, minus 7, plus 6. Now this is minus 5. Now here this value will be plus 6, and here this value will be minus 1, which is 0. Now when delta is 0, that means this equation will have either infinitely many solutions or no solution. Now if it has infinitely many solutions, then delta 1 must be equal to delta 2, it must be equal to delta 3, and it must be equal to 0. Now if we find delta 1, we'll get delta 1 as A, B, C, 3, minus 2, 7, 1, 1, and minus 1. And if we expand it about this column, we'll get A into, now this is 2 minus 7, minus 5, then minus B, this is minus 3, minus 7, minus 10, and plus C will be 3 plus 2, 5, and it should be 0. So from here we can write minus A plus 2B plus C, it should be 0, which is your option B. Now question number 23 is, when a parabola represented by this equation is translated 2 units to the left and 2 units up, the new parabola has its vertex at the coordinate points. Now first we'll find vertex of this parabola. Now we can write this equation as y equals 2x square plus 4x plus 5. We can write this as y equals 2 and this is x square plus 2x plus 1 minus 1 and then plus 5. So it will be y equals 2 x plus 1 whole square plus 3. We can write x plus 1 square equals 1 by 2 into y minus 3. Now vertex of this parabola will be at minus 1 comma 3. Now if we shift the parabola 2 units to the left and 2 units up, its new vertex will be at minus 3 comma 5 and that's your option B. Now question number 24 is we need to find value of this integral I, which is from 0 to infinite. Now what we'll do is we'll divide everything with e to the power x. We can write e to the power minus x, e to the power minus x plus 1 into dx. Now we'll take e to the power minus x plus 1 as t, then minus e to the power minus x dx will be simply dt. So we can write this integral as minus dt upon t. Now we put x as 0, this lower limit will be 2, and if we put x as infinite, e to the power minus infinite is 0, then this limit will be simply 1, or we can write this limit as from 1 to 2 dt upon t, which is nothing but ln t, and will be nothing but log 2. So value of this integral will be log 2 and that's your option B. Now here the question is we need to find which of the following option is true vis-a-vis this integral, which is from 2 to 3 dx upon under root of 1 plus x cube. Now what we'll do is we'll consider this function fx, which is 1 upon under root of 1 plus x cube in the interval 2 to 3. Now if we find f dash x, this f dash x will be minus 1 by 2 1 plus x cube to the power minus 3 by 2 into 3x square, which is less than 0. That means in this interval, this fx, it is a decreasing function. Now if the function decreases, its maximum value will occur at starting of the interval and its minimum value will occur at the end of the interval. So its maximum value will be f2 and f2 will be 1 upon under root of 1 plus 8, which is 1 by 3, and its minimum value will be 1 upon under root of 1 plus 27 and will be 1 by 28. Now we know that value of this integral, it will lie between small m b minus a to capital M b minus a. So value of this integral, it will lie between 1 by 28 and 1 by 3. So value of this integral is always less than 1 and that's your option A. That says two distinct numbers are selected from the set. The number of ways in which it can be done if the sum of selected numbers is divisible by 3. Now what we'll do is we'll partition this set in 3 subsets. So first we'll take the numbers which are multiples of 3. Say 3, 6, 9 up to 3n. And we have n numbers in this set. Then we'll have all the numbers which leave the remainder 1 when divided by 3 will be 1, 4, 7. Again, it'll have n numbers, and then finally all the numbers that leave the remainder 2 when divided by 3 will be 2, 5, 8, and again it'll have n such numbers. Now we have to select two numbers in such a way that sum of the selected numbers is divisible by 3. Now there are two possibilities. Now first possibility is if we select both the numbers from this set, then sum of these numbers will be divisible by 3. So one case is we have to select any two numbers from this set and it can be done in NC two ways. Another possibility is if we select one number of the form 3n plus 1 and the other number of the form 3n plus 2, then if we add them, then the remainders, they'll add up to 3. Then the sum will be divisible by 3. So the second case will be, we have to select one number from this set, and it can be done in NC1 way, and one number from this other set, which is again NC1. So this required number of ways will be simply NC2 plus NC1 into NC1. Now NC2 is n minus 1 by 2, and here it will be simply n square. Now we take n common, we get n minus 1 plus 2n by 2, which is n by 2 into 3n minus 1, and that's your option B. Now question number 27 is, if I is this integral from a to b dx upon under root of x minus a into b minus x, we have to find the value of this I. Now we can write this as this integral from a to b dx, and here will be minus ab plus a plus bx and then minus x square. Now we'll complete this perfect square. We'll add a plus b by 2 whole square, and we'll subtract a plus b by 2 square. So we can write this as this integral from a to b dx, and here will be under root of a plus b by 2 whole square minus ab, and here will be minus x minus a plus b by 2 whole square. Now this is a plus b whole square by 2 minus ab, so it will be a plus b whole square minus 4ab, which is nothing but a minus b whole square. And since b is greater than a, we can write this as b minus a by 2 whole square, and then minus x minus a plus b by 2 whole square. Now this is dx upon under root a square minus x square, which is nothing but sine inverse x upon a. So we can write this as sine inverse x minus a plus b by 2 upon b minus a by 2 from a to b. Now if we put x as b, we'll get this as b minus a by 2, which will be sine inverse 1, and then minus, and if we put x as a, we'll get this as a minus b by 2, which is sine inverse minus 1. So it will be minus pi by 2, and then minus plus pi by 2, which is nothing but pi. So value of this integral is pi, and that's your option B. Now here the question is, we are given this function f(x) as 3 plus x square plus 10 pi x by 2. We need to find derivative of f inverse at 3. Now we know that if we put x as 0, then x square is 0 and 10 pi x is also 0. So f0 is simply 3. Now we need to find derivative of f inverse. Now we know that f inverse of fx is nothing but x, which we can write as f inverse of fx equals x. Now we'll differentiate this function. We can write derivative of f inverse fx into f dash x equals 1. Now we need f inverse of 3, and we know that f0 is 3. So what we'll do is we'll put x as 0. So if we put x as 0, we'll get derivative of f inverse, and f0 is 3 into f dash 0 will be simply 1. We just have to find f dash 0. So if we differentiate fx, we'll get f dash x, and will be 2x plus secant square pi x by 2 into pi by 2, and if we put x as 0, we'll get f dash 0 as simply pi by 2. So if we put f dash 0 as pi by 2, we'll get derivative of f inverse at 3 will be nothing but 2 upon pi, and that is none of these. Option D. Now question number 29 is, a class has 15 students in a test with 100 questions, each question carrying 1 mark. The average score was 80. No negative or fractional marks were given on any of the questions. If the maximum score obtained by n of the student was 85, then what is the minimum possible value for the lowest score obtained? Now we are given average and we are given total number of students. That means sum of all marks will be 15 into 80, which is 1200. Now we'll get the lowest score possible when maximum number of students, they get 85 marks. So what we'll do is we'll see if it is possible for 14 students to get 85 marks. So we'll get 85 into 14 plus this lowest score L, and L be 1200. Now 85 into 14 is 1190, which is less than 1200. So it is possible for all the remaining 14 students to get this highest possible marks, 85. In that case, the lowest score possible is 10, and that's your option A. Now question number 30 is, we are given a square matrix A such that A square is equal to 2A minus I, then A to the power K is equal to which of the following? Now we find A cube, and for that what we'll do is we'll multiply this with A. We'll write A cube as 2A square minus I into A is A, and A square is 2A minus I, and then minus A will be simply 3A minus 2I. Now this A square has 2 here and A cube has 3 here, and for A square it is I, and for A cube it is 2I. That means this A to the power K, it should be K into A minus K minus 1 into I, and that's your option B. Now we'll verify it using mathematical induction. Now if we take K as 1, we'll get A equals A minus 0 into I, which is A equals A. That means the statement is true for K equals 1. Now let it be true for K equals N. So we can write A to the power N equals N into A minus N minus 1 into I. Now we multiply it with A, we can write A to the power N plus 1 will be N A square minus N minus 1 into A. Now A square is 2A minus I, so we'll get N into 2A minus I minus N minus 1A, which is 2N minus N plus 1. So it will be N plus 1A minus Ni. That means this statement is true for K equals N plus 1. So from mathematical induction, we can say that A to the power K, it must be equal to Ka minus K minus 1 I, and that's your option B.